Hello students. Hello students. Today we will discuss the procedure of IGF, isoelectric focusing. In the last class we have discussed about the creation of pH gradient in the gel. This is the whole apparatus for IEF. This is the gel containing the pH gradient from 3 to 10, and along the length of this gel, strips of filter paper about 3 mm thick filter paper is laid and it is dipped in solution of sodium hydroxide or phosphoric acid. This wick filter paper wick acts as an electrode. The wick dipped in the sodium hydroxide acts as a cathode, and the one which is dipped in phosphoric acid acts as an anode or positively charged electrode. In the beginning, when the gel is formed, a small filter paper soaked in the sample which is to be analyzed is placed at one place on the gel. It is laid on the gel. This is the filter paper soaked in the sample, protein sample, and it is placed at a point on the gel. Okay, this is the setup. This is the gel containing the pH gradient normally from 3 to 10. This is the filter paper wick forming the electrode. Okay, and this is the paper. In the beginning, a paper soaked in the sample is placed over the gel. Electrophoresis starts. The protein soaked present in this filter paper, as the electrophoresis starts, this protein comes onto the gel and forms a point of protein sample on the gel. Okay, this is the initial starts. For some time, 20 to 30 minutes, after 20 to 30 minutes, electrophoresis of the electrophoresis, this filter paper is removed because by that time all the sample of protein comes onto the gel. Okay, that means if the protein sample present in the filter paper is transferred on the gel at a place where the filter paper was placed. Here this is the diagram of how isoelectric focusing takes place. This is the gel, this is the gel. It is having the pH gradient from 3 to 10. Okay, this is the point of anode and this is the side of cathode. Here, when the protein is placed on the gel, the place of protein, suppose this is the protein, any protein, it is placed at pH between 7 to 8. And this point, this pH value, the pH value of the pH is more than, if this pH value is more than the pi value of this protein will becomes negatively charged because the protein present in the medium having a pH more than its pi, it will be it will contains more negative charge than the positive charge, and there will be a net negative charge on the protein. That means that this protein, if it has a pi value less than this pH range, this will becomes negatively charged. This will carry a net negative charge. And if suppose this protein, if placed here, the pi value of this protein is more than this range, this will be in a positively charged state or carry net positive charge. By this way, different protein will have different net charge. Some will have net negative charge, some will have positive charge. Okay, this is the point in the initial stage. Electrophoresis starts, voltage is applied, and then according to their charge, the negatively charged protein will move towards the anode, and the positively charged protein will move towards the cathode. And suppose take this way. If this is negatively charged protein, as it migrates towards the anode, this will lose its negative charge, positive charge will be added. That means its negative charge will decrease gradually, and gradually it will, as it will reach a point, suppose it is coming down this way and coming this here, suppose here, okay? As it will move towards the anode, its negative charge will be decreases, and at a place of the pH where its pi value matches, at the pi value the net charges on the protein molecule will become zero. Its negative charge will be decreases gradually, and suppose at this point its charge becomes, net charge becomes zero. So as soon as immediately when its charge becomes zero, it will cease, its movement will be ceased, and it will become stationary at that point. So this point will matches the pi value of that protein. Suppose this protein is moving this way, and by that time it reaches here, it becomes carry equal amount of positive and negative charge. That means it loses the net charge, and the charge becomes suppose zero. At this way, this place, its charge becomes zero. It will neither move this way not this way. That means it will become stationary at that place, and then it will form a band over here. Okay, and this band, position of this band will correspond to its pi value or isoelectric point. Similarly, if this is this protein, if the pi value of this protein is more than this range, pH value of 3 or 4, this protein will be positively charged at this place, and naturally it will experience a force of repulsion and will move towards the cathode. As it moves towards the cathode, it will loses its positive charge or hydrogen ion, and it will gradually, its positive charge will decreases gradually, and when suppose it comes at this point, okay, at this point its positive charge and negative charge becomes equal. It will carry no net charge. That means it will not move either this way or this way. Both way it will not move, and it will become stationary at this place. That means one protein band will be formed here and one protein band will be formed. Same way, another protein, this will also move this way, this will also move this way, and at the end So this is the migration. Migration is driven by the charge and the pH of the surrounding medium. The charge is determined by the pH of the surrounding medium and the pI value of that particular protein. Okay, if the pH of that place, medium of place, is more than the pI value of that protein, the protein will exist as a positively charged ion, and if the pH value is less than the pI value of that protein, it will exist as a positively charged ion. Okay, the positive will carry a net positive charge. That means the net positive charge molecule having net positive charge will move towards the anode, and for molecule having net negative charge will move towards the cathode. And by that time, as they will move, they encounter the, as they move from here to here, they encounter the decreasing pH, and decreasing pH means addition of hydrogen ion, and their negative charge will decrease, and by that time it reaches this position, both negative charge and positive charge will, the number of negative charge and positive charge will be equal to each other, and the protein molecule will carry no net charge, it becomes stationary over here. That means at the end, suppose a sample contains 3 type of protein molecules, 3 samples of protein molecules having different pI value. So at the end, we will get 3 bands of protein. All the protein molecules will be in their Zwitterion state, having no net charge. So one band will be here, another band will be here, and this one the okay. So at the end we will get 3 band of protein which will correspond to their isoelectric point. So that means by the difference in their isoelectric point, the protein molecule having very much similar molecular weight can be separated due to difference in their isoelectric point. Okay, so this is the process, and this process is known as isoelectric focusing. Okay, so this is the process. We are in the initial stage. This is the position of the protein in the beginning, and having different charges depending upon the pH value of that very place. And if the protein molecule is present at a place of pH range between 7 to 8, and this pH range is higher than the pI value of this protein, this protein will carry additional negative charge, and it will migrate towards the anode. As it moves towards the anode, the pH value will decreases gradually, and its negative charge will decreases gradually, or hydrogen ion will be gradually incorporated into it. Okay, and by the time it reaches at a place which is equal to its pI value, it will have equal amount number of positive charge as well as negative charge, and that means it will carry no net charge, acts as a deuterion, and it will not be attracted by either of this electrode, and it will become stationary at that place which correspond to its pI value. Okay, similar way, if the protein is present at a place of which have a value of pH which is less than the pI value of that protein will carry additional positive charge. Okay, and this protein will move towards the cathode. As the protein moves towards the cathode, the pH value gradually increases, and its positive charge will gradually decrease, and by that time, suppose this place, at this place it will have equal number of negative charge and positive charge. That means the net charge becomes 0 and it will become stationary. It will no more be attracted by cathode, or it will no more be have any driving force for its mobility. That means it will become stationary. Over here, that means at this place it will carry no net charge, or it will carry equal number of positive charge and negative charge. A band will be formed here. Similarly, another band will be formed here, and one band will be formed. Suppose this carries 3 proteins, so we will get, at the end we will get 3 bands of protein at a place which corresponds to its pi value. Okay, hope you will have understood this process. Thank you very much.